Hello everyone, my name is Joseph and welcome back to Joe Analytics. In the last video, we learned about what database is and how it is used in the data-driven world. If you haven't seen that video yet, check the link below in description. In today's video, we're gonna learn types of database. So just get right into the topic. Types of databases. There are nearly a dozen types of database. We have noted some of the most commonly used categories of databases. Hierarchical database. A hierarchical database is a data storage model that organizes data in a tree-like structure with parent-child relationships between records. For example, imagine it like an organization chart where the CEO is the root, sits at the top, and each department is a child reports to the CEO. In turn, each department can have its own subdepartments, and so on. These hierarchical databases are simple and easy to understand. The tree-like structure is intuitive and easy to grasp both for users and developers. It mirrors familiar concepts like organizational charts and file systems, making it accessible even to those with limited technical knowledge. These databases are efficient in data storage and retrieval for certain types of data. For data that naturally falls into hierarchical structure, example organizational charts, product categories, these data storage and retrieval can be efficient. Accessing child records from their parent is straightforward, requiring minimal processing. Fast retrieval of data at the top of the hierarchy. Since the root node sits at the top of the tree, information stored there can be accessed very quickly. This is beneficial for data that is frequently needed, like company information in an employee database. And also, the data can be very easy to add and delete. That means adding or deleting records within the hierarchy is usually straightforward. Adding a new child to an existing parent or removing a child from its parent only involves modifying a single record. And these databases also has less data redundancy. Compared to some other models, hierarchical databases can minimize data redundancy by storing shared information. Example, department name. Only once at the parent level instead of duplicating it in every child record. Next is relational databases. These are the most common type of database, employing a tabular structure with rows and columns. Think of it like a spreadsheet where each row represents a record, example customer information, and each column represents an attribute, example name, address, phone number. These relational databases are very efficient for storing and retrieving related data. Also supports complex queries using standard language SQL, that is structured query language. However, these are less flexible for storing unstructured data. Example videos, images, etc. And the examples are relational databases examples, Microsoft SQL Server, Oracle, MySQL, PostgreSQL, etc. Both SQL Server and Oracle are commercial databases, means you have to pay for a license to use all their features. Whereas MySQL and PostgreSQL are open source databases and is free to use. There are other databases like centralized database, distributed database, network database. Though these databases can all be used in conjunction with relational database, they represent different ways of organizing and accessing data within the relation mode. Now let's look at the NoSQL database. As opposed to the rigid structure of relational databases, NoSQL databases offer more flexibility for storing and managing various data types, including structured and semi-structured data. These are often used for big data applications where massive volumes and diverse data formats are involved. NoSQL databases are built to scale effortlessly, manage vast amount of data effectively, and adapt easily to store various types such as JSON, JavaScript object notation, BSON binary JSON, or XML format, among others. NoSQL database examples are MongoDB, Cassandra, Amazon DynamoDB, Couchbase, etc. Cloud databases. These are databases hosted on cloud platforms like Amazon Web Service, Microsoft Azure, or Google Cloud Platform. They offer on-demand storage, scalability, and pay-as-you-go pricing, making them ideal for businesses with fluctuating data storage needs. Cloud databases offer scalability, ensuring that you can easily accommodate increased data volumes without worrying about infrastructure limitations. Moreover, their cost-effective pricing models enable businesses to manage their data without breaking the bank. With the convenience of accessibility from anywhere with an internet connection, cloud databases empowers teams to collaborate seamlessly and access critical information whenever they need it. Cloud database examples are Amazon RDS, Microsoft Azure, Google Cloud Platform, etc. Graph databases. These specialized databases store information as nodes, that means entities, and edges, means relationships between them. This structure is particularly useful for modeling interconnected data like social networks, knowledge graphs, recommendation systems. These databases are efficient for querying relationships between entities, ideal for complex network analysis. Examples are OrientDB, Neo4j, Amazon Neptune, etc. In-memory databases. As the name suggests, these databases store data in RAM for ultra-fast read and write operations. They are very ideal for applications requiring real-time data processing and low latency, such as fraud detection and stock trading platforms. These are extremely fast performance, suitable for real-time applications, and some examples are Redis, Memcached, Apache Ignite. Now let's look at object-oriented databases. These databases store data as objects, encapsulating data and related functionalities within a single unit. Object-oriented structures aligns with object-oriented programs and simplifies modeling complex data relationships. And some examples are Object Store, Versant, Gemstone, etc. That's all for today's video. In the next video, we'll learn about what is DBMS and RDBMS. Thanks for watching and have a great day ahead.